This video is going to go over some basic exponent properties that you should have worked with in the past. So what I'd like everyone working off of today while watching this video is this single sheet reviewing our fundamental exponent properties. We're going to start with the first rule, which is the multiplying exponent rule. So first I just want you to take a look at the left. You'll see that we have, one second, let me just get a highlighter. So you'll see that we have the rule on the left, more of a worded explanation of the rule in the middle, and then some examples we're going to try together on the right. So if you remember, again, this is a rule that you work with every time you manipulate, multiply polynomials. You try to get an equation into standard form. You do this probably without even thinking of it as being a rule. So when you multiply like bases, right, when multiplying bases that are the same, you add their exponents. And if they have a coefficient, you multiply them. So we take that a plus b, we add it to that base of x. So looking at the right, I want you to try both examples. So maybe just pause the video for a second, try the two examples, and then play. So since in this first example, we have 5 squared multiplying with 5, I just want to indicate that that second factor has an exponent of 1. So they're like bases of 5. So the base of 5 would now be raised to an exponent of 3, since 2 plus 1 is 3. Now, because this is all numerical, you could actually calculate that 5 to the third is 125. In the second example, the like bases, the x's, if I multiply them, I would get x to the 7th, adding 2 plus 5, and then multiplying the coefficients in front would give me a coefficient of negative 12. So again, that rule hopefully feels like a rule that you recall because you've used it a lot this year in just manipulating expressions. Multiplying, combining like terms would be, something you would do after you used this rule. Okay, dividing exponents. So sometimes this might even look more like this, like if you had x to the a over x to the b. In this case, when you have like bases and you're dividing, you would subtract those powers. So x to the a minus b. And then if there were coefficients in front of x, then you would divide the numerical coefficients. So again, take a moment, try both examples, pause the video, and then we'll go over them. So 4 to the 8th over 4 to the 2nd. So you want to be careful here. You're not dividing the 4s, just 4 divided by 4 getting 1. You first need to take care of the fact that both of these 4s have an exponent. So we're going to treat these 4s like we would if they were just a variable. They are like bases of 4, and 4 to the 8th divided by 4 to the 2nd would be 4 to the 6th. 8 minus 2 is 6. And then if you did calculate that, that would be 4,096. Now, if you had manipulated the exponents first, this wouldn't be really using the exponent rule, but just if you had done this differently because you could because it's numerical, if you had calculated 4 to the 8th, you would get 65,536 divided by 4 squared, which is 16. This would also get you to the 4,096. So this is without using the exponent property, and then what we did first was using the exponent property of, dividing like bases, we subtract their exponents. And then in the second example, you would just get n to the power of 5, since 9 minus 4 is 5. Okay. Moving on to power of a power. So when you have an exponent being raised to another exponent or to a power, x to the a being raised to the b, we have one base of x, but we have two different exponents. You're going to multiply those exponents. So if we take a look at the examples, take a moment to try both examples. Pause the video. So 4 to the 2nd raised to the 3rd. Again, because this is numerical, there's more than one way to do this. But if we're going to use the exponent properties, 4 to the second to the third means I'm going to take 2 and 3 and multiply them and get 4 to the sixth, which earlier we got as 4,096. X to the seventh raised to the sixth, x to the 42. 7 times 6. Okay. Now, power of a product. This really goes into real understanding that when you have multiple factors being associated to the same power, that every single factor has to be raised to that power. So here we have x in the parenthesis, x and y both just have exponents of 1, but now they're being raised to an outside power of a. This would turn into x to the a times y to the a. So to find the power of a product, you find the power of each factor, and then you would multiply those factors. They would still be multiplying together. Okay, so take a minute to try both examples. Pause the video, and then we'll go over them. Okay, so right now 5 is being raised to the first, but the outside power is a 3. So 5 is going to be raised to the third power, 1 times 3. Y is currently being raised to the sixth, and outside it's being raised to the third. 6 times 3 is 18, so y is now being raised to the 18th. And because 5 to the third you can calculate, 125, y to the 18th. So it's really just the numerical values. If they're being raised to a power, you would calculate them. You typically wouldn't leave it as 5 to the third. And then here, 3 is being raised to the first inside the parenthesis and being raised to the fourth outside. So 3 is going to be raised to the 1 times 4 power, or the fourth. A is going to be raised to the 8th, 2 times 4. And then 3 to the 4th is 81, so we could rewrite this as 81 a to the 8th. Okay, and then the last exponent property I just want to review is that any non-zero base, any number except for 0 that is raised to the power of 0 is equivalent to 1. We can actually use a property we used earlier, the division property. Let's say you had x, well, let's use numbers. Let's say you had 2 to the third divided by 2 to the third, right? If you're using the division rule, you would get 2 to the 0, right? 3 minus 3. But let's really think about what we have there. 2 to the third is 8. 8 divided by 8, anything divided by itself is 1, right? Even 2 to the third over 2 to the third. Yes, we get 2 to the 0, but what does that really equal to? Anything divided by itself is 1. So x to the 0 really means you divided something by itself, you're going to get 1. So anything raised to the 0 power, as long as that base is not 0 itself, should give you 1. Okay, these bottom two properties, actually this property, negative exponents, it's something you may have seen in the past depending on the sequence in which you took your math courses. If you never took Math 8, if you were already in Algebra 1 in 8th grade, you might not have seen this property. We're going to come back to it probably by Thursday. But fractional exponents is a property we're going to talk about a little bit later in this video, and that's going to really be the first lesson we start tomorrow. So I'm going to leave these for now, and we'll come back to them. So now what I would like you to do, since you only had that one sheet that you just worked off of, maybe take out a piece of paper, or if you want to write on the back of the sheet, we're just going to review some of these properties. I'm going to give you a couple of questions to try. Okay, so maybe pause the video, get yourself something to write on, and then give this first one a try. Okay, so you should see for this one, we're using the multiplication property. We have like bases of x. X to the 6th times x to the 3rd should be x to the 9th. You should be adding those exponents, 6 plus 3 to get you 9, since you're multiplying the bases. So for each of these, you might want to just pause the video for a moment so that I don't just immediately start going over it. try it first and then listen to the video. So here we have a power being raised to a power, so we're going to multiply those powers. So this should be x to the 8th, 4 times 2. Another way to think about this, the 2 means that you're squaring what's in the parenthesis. So you could also say x to the 4th times x to the 4th, and then you could use the multiplication property, which says if you have like bases, add the exponents, you're going to get to the same answer, but now you're doing it using a different property, 4 plus 4. This becomes a little less efficient if the outside power is a bigger number. You might not want to write it out so many times, but just know that these are equivalent ways of doing this problem. Okay, so anytime I don't see an exponent, I like to indicate it. So I'm going to put a 1 with the y. And again, you can do this one really 2 ways, but using the power to a power rule, x is going to be raised to the 8th, 4 times 2. Y is going to be raised to the 2nd, 1 times 2. So 4 is being multiplied with 2. Again, power to a power. And then we're raising the y squared, so 1 times 2 as well. And if you thought about this a little bit differently, you could have expanded this. Since x to the 4th y was being squared, multiply it by itself twice, then you would use the multiplication property. 4 plus 4 gets you x to the 8th. 1 plus 1 gives you y to the 2nd. So again, if I don't see the exponent, I'm going to indicate it. So the division rule, this should be x to the 7th. Since x to the 8th over x to the 1st, I would do 8 minus 1 to get 7. So the power to a power rule applies to factors and that are multiplying and also factors that are dividing. So this would really be x is being raised to the 1st and so is 3. So I'm going to multiply the 1 with the 2 and then also this power of 1 with the 2. So I should have x to the 2nd over 3 to the 2nd, and because you can rewrite that as 9, I would write that as x squared over 9. Again, you could also think of this as x over 3 times x over 3. Now I'm multiplying again. Remember with fractions, you're multiplying the numerators, you're multiplying across with the denominators. So x times x would be x squared because I'm adding those exponents. 3 times 3 would be 9. So just another way to look at it. So for this one, you want to be careful that you have to really apply the exponent, especially in that denominator, before you do any type of division. And always think about order of operations, right? So exponents would come before any kind of division. So let's look at that denominator first. So I have 2x to the 5th in the numerator divided by both 4 and x are being raised to the 1st. So outside that power is then being raised to the 2nd. So this is going to become 4 to the 2nd, x to the 2nd. So that would be 2x to the 5th really being divided by 16 x to the 2nd. Now I can look to my division. So if I'm just looking at the x's, x to the 5th is being divided by x to the 2nd. So that means I should have x to the 3rd, 5 minus 2. 2 over 16, I can divide those and get 1 over 8. So you could write it like that, or you could treat 1/8 more as like a coefficient and write x cubed to the side. They're both correct. Okay, we're going to spend these last couple of minutes I'm going to introduce the exponent property we're going to be really learning tomorrow in lesson 1. But I first want to see if you see any pattern with these 3 equations. So I'm telling you these 3 statements here are true statements. And do you notice anything interesting or anything that maybe any pattern that you see between the radical side on the left side of this equation and the exponent on the right? Each of these has a fractional exponent. So again, pause the video, take a minute to look at it, and then we'll discuss what is happening here. Okay, So if you notice, I'm going to first fill in the exponent. And if you remember, when we don't have a root indicated, that's because it's a square root. So really there's a 2 there that we just aren't writing. I'm just going to point a couple things out. Okay, so then each of these didn't really have their exponent because usually if an exponent is 1, we don't indicate that. But if you notice, the pattern I wanted you to see was that you can see some similar numbers on both sides of this equation. So for all 3 of these, what I wanted you to see is that the exponent, let's say we're looking at the radical expression on the left side of the equation, the exponent of the radical term was the numerator of the fractional exponent on the right side. And the root, the number that defines the type of radical you're looking at, is the denominator of that fractional exponent. So this is what we refer to. Often I'll say power, which is just another word for exponent, over root. And remember, sometimes we'll use the word index. That's another way to describe the number in the hook of the radical. So a fractional exponent is another way of expressing a radical. It's just a different form. Or you could say a radical is another way of expressing a fractional exponent. So if you typed into your calculator right now 4 raised to the power of 1/2 or the square root of 4, you're going to get 2. If you type in the cubed root of 8, you're going to get 2. If you type in 8 to the 1/3, you're also going to get 2. Same thing with 16. The 4th root of 16 is 2, just like 16 to the 1/4 is 2. So what we're going to try to explore right now is just getting comfortable with how do we turn either a base raised to a fractional exponent into a radical, that would be equivalent, or a radical expression into an equivalent number raised to a fractional exponent. Also, if you go back to your sheet, maybe we can start there, that last property you'll see here. So we just said power, so the root is the n, and the power was the m. You can also, this property, just to show you with the radical side, it can actually be expressed 2 ways. That exponent of m could be inside the radical, directly being applied to that base, that x, or it actually could be raising the entire radical to the power and be outside of the radical. They're both equivalent forms. So if I had x to the 1/2 and I wanted to rewrite that as a radical, I have power over root. This would be x to the 1st under a square root, which really you don't typically write the 2 or the 1 here, so just the square root of x would be equivalent to x to the 1/2. And then here I have x to the 4/5. That would be equivalent to having the 5th root of x to the 4th. And you also could write that as the 5th root of x all raised to the 4th. Like both of those are equivalent to each other. Okay, we're just going to bear with me. I know this is long. Just try a couple more with this property since it's new. This is also just something that's going to be in your packet, so you'll see that again tomorrow. Okay, we just did this one. So if you weren't paying attention or you missed the one I just went over, this video is long, I apologize. Try this one. Just write it in simplest radical form. And it should be just the square root of x, right? This hook index number would be a 2. This exponent would be a 1. It's always going to be power. The numerator of the fractional exponent is the power under the radical, and the denominator would be the root. And for this one, again, you could just simply write the square root of x because the 2 is implied and the 1 is implied. Okay, so again, give this one a try. And it's always power over root. So it should be x to the 5th underneath a 4th root, or you could do the 4th root of x all raised to the 5th. Both of those are equivalent. So we want to be able to go both ways. So not only do we want to be able to take something raised to a fractional exponent and be able to express it in radical form, we also want to be able to take a radical expression and be able to rewrite it as a base raised to a fractional exponent. So here I can see that I have a power of 3. When you don't see something in the hook of the radical, that's because it's a square root, so you have to know that there's a 2 there. That 2 is not written, but it's implied. So this would be x to the 3 over 2. Power over root. Give this one a try. So it should be x to the 7 over 4. Now, I promise we're almost done. I just wanted to do a couple more combining rules. So the rule of multiplying like bases, you should be adding their exponents. So yes, these are not maybe the nicest numbers to add because they're fractions, they don't have common denominators. So you could sit there and add, 1/4 and 2/3 by coming up with a common denominator of 12, or you could use your calculator and add 1/4 and 2/3. You should get 11 over 12. Again, if you're not using a calculator, you'd be converting this by multiplying it by 3 over 3 and turning that into the fraction 3/12. This you'd multiply by 4 over 4. That would become 8/12. 3/12 plus 8/12 would be 11/12. But again, you would do that in your calculator. And then let's say I was asked to write this in a radical form. That 12 would become the root, and the 11 would be the power still under the radical, or it could also be outside of the radical. So let me just write that both ways for you. So this would be the 12th root of x to the power of 11. All of those are equivalent. All right, I think we're going to stop here. So tomorrow we will work on really diving into this new property of fractional exponents. I'll hand out the packets. Your first homework will not be due until Thursday, so you won't even have a homework packet with you until tomorrow. Thank you for being so patient. Hopefully you got something from this video and you were able to review the properties of exponents, and you'll come in tomorrow with this foundation built, and we will continue on with exponent properties. Thank you, everybody.